Alright everyone, this is chapter 7.6 video lecture. This is over determining molecular formulas. I teach this second because you have to know the empirical formulas before you can know the molecular formulas. So, we're going to review real quick last lesson on empirical formula. I need you to go through this warm-up right here and push pause now until you're done. Hopefully you're completely done, and we're going to go ahead and answer these. Right here you should have change 65.5 grams of carbon over to moles of carbon. You should have used your notes from last class. And then equals 5.45 moles of carbon, sorry. For hydrogen, 5.5 grams of hydrogen, 1.01 grams per mole. When you do that math, it should give you roughly the same. Yep, 5.45. But they're going to have the same subscript. And then you're going to do the same with oxygen. That's an M. Alright, now 1.81 there. I'm going to divide all of these numbers by the smallest one, which is oxygen. And I'm going to get, when I divide all of these numbers by 1.81, I'm going to get, my formula is C3H3O. C3H3O. Do the same on the next one, and just follow the steps we did up here. Change everybody to moles, divide by the smallest of the three, and those are your subscripts, okay? Can't seem to get that to work, so best of luck. Now, I'm just going to give you the answer to the next one. Li2CO3, I don't know what just happened there. Let me see if I can erase that. Alright. There we go. Li2CO3. Alright. We're going to move on to molecular. Oops. Molecular formulas are just a multiple of the empirical formulas. Now, this is the actual formula. This is the one found in nature. Your empirical formulas tend to be what really exists in, I know, buddy. Your empirical formulas tend to be what really exists for ionic, but for covalent, they never show up as the empirical. Very, very rarely do they show up. A lot of times, it's a multiple of the empirical. So see here, the, glucose is a multiple of its empirical formula, okay? All right, so, I broke it. There we go. In order to find the molecular formula, you have to be given something called the formula mass or the molecular mass. Now, I'm going to use the term formula, but if you see molecular mass, that's the real mass, okay? So write that in underneath formula mass. All right, to compare the two, you'll take the formula mass and divide by the empirical. So F over E, formula and divide by empirical, and that gives you the multiplier. Now when I say multiplier, I mean this number right here, okay? You're going to multiply the the empirical formula by some number to get the molecular. Let's do a couple of examples. Let me erase all this. Okay, so your first example, you need to find the molecular formula of a compound, and they give you the empirical formula, and they give you the formula mass. Well, you've got formula mass. What do you not have? You don't have the empirical mass, but guys, you have the empirical formula. So when I need to find my mass here, I just add up the masses of each part, like we've been doing, molar mass. That should be 13.01, right? So 13.01 grams, O2, excuse my terrible math, O2 grams, and then up top, I'm going to put my formula mass of 78. So it's 78 basically divided by 13. And that'll give me my multiplier. My multiplier here is 6, so I'm going to take CH, and I'm going to multiply the whole thing by 6. Hopefully you can distribute C6, H6. This is cyclohexane. You don't have to memorize that. Okay? Take a minute and look over this again if you need to. That was a very simple version. I'm going to move on to where it's a little harder now. Okay, harder version. Whoopsie. Harder version is this one where you have to find the empirical mass first to find the molecular.
Hey,
First step is always to find the empirical unless it's given to you. So what we're going to do here, we're going to wait and use this formula mass in a few minutes. But I'm going to use this stuff and find the empirical first. Okay, you know I always have to give you the hard version so that you'll know what to do if you're given that on a test. So what I'm going to do here is change my percentages to grams. Wow, right better than I am because this looks bad. 39.9 grams carbon. Change all of them to moles. Divide appropriately. Shh. Crazy animals over here. Let me check that math. I got 3.32, but that doesn't look right. Alright, yeah, it's right. I'm trying to fix this stuff. Okay, so that's how many moles of carbon. I'm going to do it again for hydrogen. Okay, when you divide there, you should get 6.63. I'm starting to run out of space. And then I'm going to do my oxygen. Whoops. 53.4 grams of oxygen. So I'm going to divide by 16 on the bottom. So there are 16 grams per mole there. Oh my heavens. 53.4 divided by 16 is 3.33, which is basically what we had for carbon up there. So I'm going to divide all these guys by the smallest, which I'm just going to pick as 3.32. It's close enough. You'll divide these and you'll see that you've got 1 carbon, 1 oxygen, and 2 hydrogens. Now, that's your empirical formula, CH2O, which you saw earlier in the notes was the same empirical for glucose. Let's see if this is glucose though. So now we're going to take our formula mass, which is 60, and divide by our empirical mass, which we get from right here. You need to take 12.01 plus 2.02 plus 16 and add all that together. And you should get roughly 30. okay, when I add all that together. So my multiplier in this problem is 2. I'm going to take this whole thing and multiply by 2. When I do that, my real formula, my molecular formula, is C2 now, H4O2. C2H, I don't know what happened, 4O2. Okay, so that's how you find molecular formulas. The first things you've got to have an empirical formula, and you've got to have a formula mass or a molecular mass. Those are the 2 bits, all right? Now, let's see. You need to be working on homework set 7-6. And remember, you need to make sure you have all the information that you need. Ask me any questions you have in class, okay? Good luck.